So, Eric.
I'm someone that really believes that it's really important for your tools to not be complicated to use. You want it to be really easy, and that the work that you do is supposed to be the complicated part. My name is Eric Codrea, and I'm at the APS, and that's currently what I'm working on to build out. So, as you guys know, this is the scientific workflow. You have your experiment, you do your data reduction, you analyze your data, and eventually the goal is you want a publication, you want a presentation, you want to do something very visible with that. And where Blue Sky operates is a lot in the experimental section, and it wants to help you to be able to successfully do that part so that all the other steps can be done correctly, and then you can finally get that publication presentation moment. Now, could I get a quick show of hands who here uses Blue Sky? See, I mean, we're going to go over this slide. This might be a better slide for a spec conference, not for this one necessarily, because there's a lot of you over here. But we like Blue Sky. It's based on Python. That means it's very easy for novel users to use. It's a lot of things that my generation especially learns in college. It allows for interdisciplinary teams because of that common language. I've never worked in a synchrotron before February. Before that, I was a roboticist. You've got the integration with the automated workflows, the data management. You have a very rich library of tools. A lot of the world uses Python. And because of that, you also have better integration with modern equipment, with your area detectors. It's really easy to integrate those things into Blue Sky. And lots of pre-built devices. We have this repository called APS Tools, and inside of it, anyone at the APS is able to use any of the devices that have already been done once, and they can just get up and running with their beamline way faster than having to build everything from scratch. It handles both multidimensional and asynchronous event-based data sources. Data can be saved in any format. It's really easy to get new features in, and can be integrated honestly with any other Python stuff you have going on. So it's a very lovely software to use. And we have this vision of deploying it in the following way. At the top, you have your beamline scientist or your user. He interacts with the IPython console, the Q server perhaps, maybe a Jupyter notebook, whatever he feels most comfortable with. And then he goes on, he makes his experimental instructions, he's able to do the Blue Sky data collection. The problem that we have at the APS is that we have a lot of different science going on. We've got HEDM, we've got XPCS, ISN, USAC spectroscopy, you name it. And the science requires different approaches, obviously. These are very different types of science, but that doesn't mean that the tools for the execution are not the same in the very end. So Fani Rodolakis tomorrow is going to cover a bit more of this stuff in depth, but what we want to do is we want to have a way of organizing everything so that we can deploy the same tools on multiple beamlines in an automated fashion, so it's very easy, and we can really crank out production because we have a lot of beamlines at the APS. And we wanted it to be highly customizable so you can do the type of science you want to do in the way that you really want to do it, without having to change the structure that is across from beamline to beamline. Because a very similar structure creates a knowledge base inside of the community. All of a sudden, you don't need a Blue Sky expert to help you out with your stuff. You can go to the beamline next door and they're like, hey, how did you guys solve this problem? How do you do X, Y, Z? And then that knowledge propagates. And this type of unified backend, it makes it very easy for you to have an enhanced front end and for you to actually visualize your data. So how are we making this work? So in the dashed lines is stuff that we're really working on still, and we haven't deployed at all. In the solid lines is stuff that we have deployed so far and we're going ahead with. So first of all, we have a copier template. Basically, it takes a YAML file. It asks you a couple of questions, you answer them, and based on that, it creates the package specifically for your beamline with where your data is going to get stored, your paths, etc., your IOC names. Inside of that, there's a typical Python package. Everyone knows how to install a Python package. It's a very trivial situation. And there you have your tools and all the other stuff. Now, we want to grow into a point where we have all of this Dockerized, so then it's even easier for us to deploy this stuff long-term. And we're still working on things like Kafka servers, tiled servers that Dylan mentioned, and the standardized visualization tools. In terms of deployment, it's one of those situations where the more you have to deploy, the more problems arise, especially if it's very unique. So we have Blue Sky now running on 6 beamlines. We're deploying it to get it running on 4 beamlines, and it's planned to run on another 4 beamlines. So the total number of beamlines to run Blue Sky at the APS is 14 beamlines. That's a lot of beamlines for a small team. We're a 3-person team at the APS. So it's a lot of bandwidth that every single person has to be able to make this happen on top of developing our existing tool base. And Copier, the tool I was mentioning earlier that allows us to do the structure we described above, makes it easy to make these changes in multiple locations if the same base template is used. Now, a lot of beamline scientists have frameworks that they are more comfortable with, such as Spec. That's something that we have encountered quite a lot at the APS. And especially when they're commissioning and stuff's kind of going hard, they want to use the tools that they're familiar with. So how do we address the second set of problems? Well, we have documentation, and we have a documentation for APS tools, the thing I mentioned earlier, where all devices and plans that are used across the APS are stored. And then we have Blue Sky Training, our training manual. And that's a really big part of how we try to address the problem of getting people familiar with that. What we ended up finding out is that when you have very sparse documentation, no one checks it out, because it's like, okay, there's nothing here worth reading. I'm going to just ask someone. I'm going to call Eric. There's a very nice point where you have enough documentation. It's not too daunting. People are very eager to use it. They want to use it. And that's when you have your best amount of documentation. But then it's very easy to go on the other side of the spectrum, and then you have too much documentation, and it's very, very overwhelming for certain people. I see some of you over there shaking their heads. And because they find the documentation so overwhelming, they're like, everything's on fire, it's burning, I need to, really quick answer, I don't want to scare through this because I was supposed to do this 2 weeks ago, and this is the day I'm supposed to get my stuff running. So again, Eric, help me. And the other resources we have is our Blue Sky team. But because we're 3 people and a lot of deployments going on, this is actually the calendar of one of my teammates, Peter Jemian. This is him talking individually to every single beamline that has a specific problem that he knows how to solve because he did the deployment on the specific beamline. So his whole day is spent actually trying to get the deployment to work as opposed to developing more stuff for the APS, where Peter's an amazing individual contributor, and he's not able to 100% utilize his skill set because he's stuck just always putting out fires as opposed to adding more and more features. Long-term, beamline scientists need to be able to debug these things without a BC, beamline control team member present at all times. And like I said, time spent in support is not time spent in development. And as you guys know, beam time is very stressful. Everything's on fire. And documentation is a way to have a fire extinguisher, but no one wants to use a very stressful fire extinguisher. And people don't know stuff off the top of their head, so they call the beamline expert. And beam time is too precious of a resource to waste. So we have to find a way to make the most of it. Now, I've been working with Matthew Shurkar and Michael Prince at the APS, and they're developing a scientific companion called Calms. And what it does is it has a vector database document store. What we are trying over there is we're storing our training manuals. We're storing APS tools. We're basically storing anything that you would need to know, use to operate said beamline. And then you have it in such a format that you're able to have a conversation with it. And now you have another line of defense before you go to be a Blue Sky expert or before you have to try other types of debugging. It's a very good gateway over there. Now, this is how it kind of compared with, oh, whoops, wrong slide. So this is the way the structure is going to be used. We're going to feed it APS tools, Blue Sky Training, any other documentation, and then the user is able to engage with the chatbot, and once that he has a satisfied answer, he's able to use his console session, the Q server, or the Jupyter Notebook to actually go through with all of this stuff. And the goal is to be able to aid the researchers in creating devices and provide answers that can be extrapolated from said documentation. So these are the examples I wanted to get to. One of the devices that we have in our APS tool, suite of tools is a console micrometer. It's already been done once. It's used at multiple places at the APS. There's absolutely no need to remake this OFID device. But some people that want to program their own beamline do not necessarily know about everything that is inside of APS tools. So compared to GPT-4, I asked this like, hey, are there any console micrometer devices I can use inside of APS tools? Obviously, it wasn't specifically trained or maybe like barely scraped the APS tools database. and they believed there was no such class, tried to create a random OFID device, and with columns, after feeding it this stuff, it successfully found the OFID device class inside of APS tools. Follow-up, how can I use the device? Columns provided a code snippet of how to instantiate the device. It gave an example about how to import it, and some other example commands. On top of that, if you, for example, want to know, it's like, oh, how can I align my beam? Do I need a specific plan for that to create from scratch? Again, APS Tools has a lineup plan. Columns was able to really quickly retrieve that, gave the arguments needed to use said function, and even told you that if you're using QServer, you should use lineup too, because lineup does not work with aligning the plan does not work with lineup when using the QServer. So in conclusion, what I wanted to get to, Blue Sky offers a versatile and efficient framework for managing diverse scientific workflows at the APS, allows for both standardization and customization. Templates are a great way to distribute the same package structure without having one central package to different user needs. And integrated with columns and the use of language models streamline the learning curve, making it easier for users to operate without extensive domain knowledge. In the future, we're looking to implement Docker and improve the template for quicker beamline commissioning. And finally, enhance the documentation for more in-depth problem solving using columns. Thank you very much. I would.
Okay, so I guess we have time for one or maybe two questions.
Did you do any evaluation on the models you use within columns, like locally hosted, open source versus commercial services?
So I'm on the deployment team. That's something that Matthew and Michael were specifically working with. Currently, we found that the GPT still worked better than anything else. We have not tried the newest open source models. The last time we've tried any new models was around August, I believe. So since then, the soda might have changed. Okay, yeah, go for it.
Would be interesting because we've been doing knowledge assistant tests as well and have feel that Vicuna as a local model, GPT-4 and Mistral now also with varying results. So it would be really interesting to see what other people are observing with different model flavors.
Awesome. I'll keep it in mind. Thank you very much.
How do Beamline staff interact with this? Can they email it?
That is not currently a feature. But it actually would be a very good solution with something that we're currently struggling with. So at the APS, all Beamline computers are now on a subnet due to security reasons. So we've been trying to figure out an easy way for people to be able to communicate with the internet without having to put the machines themselves on the internet. So thank you very much for that suggestion, Dan.
Thanks. I think. Okay, thanks.